Hi, I'm Swarupa Sail, course instructor for Geotechnical Engineering 1. In this presentation, we will go through hydraulic gradient, Darcy's law, and validity of Darcy's law. To begin with, we will know what is permeability. It is the measure of the soil's ability to permit water to flow through its pores or voids. Usually, water flows from points of high energy to points of low energy. Soils are permeable due to the existence of interconnected voids. In this figure, we can see a datum line, that is the reference line, above which the head of water is measured at point A. So the distance between the reference line, that is datum line, and the water table at point A is HA, which is known as total head. Similarly, the distance between the datum line and the level of water at point B is HB, which is known as head at B, that is total head. And the difference between the head, that is HA minus HB, is equal to delta H, which is the head loss. Here we can see that the soil is sandwiched between two impervious soil layers. So by the time the water flows from point A to point B, there will be head loss. So that head loss is given by delta H is equal to HA minus HB. Next we'll find out what is hydraulic gradient. Water below a groundwater table surface is flowing under a hydraulic gradient. And this hydraulic gradient is the slope of the free water surface in the direction of flow. So we had seen that at point A, the total head was HA, which can be written as H1, and the total head at point B will be HB or H2. So as the water flows from high energy point to low energy point, we will find out what is delta H. So head loss, that is delta H, is equal to H1 minus H2. Let the distance between point A and point B be given as L. And hydraulic gradient I will be the slope of the free water surface. So it will be delta H divided by L, where delta H is head loss and L is the distance between points A and B. So here again a soil sample is shown and we have considered two sections, that is A and B. The head at point A is HA and head at point B is HB. And by the time water flows from A to B, there will be head loss, that is delta H. That delta H is HA, that is H1, minus HB, that is H2. So delta H is head loss and L is the distance between the points A and B. So hydraulic gradient I is equal to this head loss, that is delta H, divided by the distance between the points considered, that is L. Now we will go through what is Darcy's law. It is an equation that describes the flow of a fluid through a porous medium. Groundwater flows from high elevation to low elevation and from high pressure to low pressure. The gradients in potential energy drive groundwater flow. So due to gradient, water flows from one point to the other point. Darcy's law says that the velocity of flow V is proportional to the hydraulic gradient I. So V is directly proportional to I. So when we remove this proportionality sign, we get a constant, that is K. So V will be equal to K into I, where K is constant of proportionality, or it is also known as Darcy's coefficient of permeability. When I is equal to 1, V will be equal to K. Hence, coefficient of permeability is defined as the velocity of flow through soil under unit hydraulic gradient, that is I equal to 1, and has the same unit as the velocity. So unit of K is equal to unit of velocity itself, that is centimeter per second or mm per second or meter per hour, or also it can be in terms of meter per day. For laminar flow through saturated soil mass, discharge per unit time is proportional to hydraulic gradient. Darcy found that Q is proportional to the hydraulic gradient I. So Q is equal to area into velocity. Velocity is K into I. So Q is equal to A into Ki. Q is rate of flow or discharge per unit time, that is flow out of the sample. A is the total area of cross section of flow perpendicular to the direction of flow. And hydraulic gradient I is equal to delta H divided by L, which is equal to H1 minus H2 divided by L. So in this figure, we have a soil sample whose cross-sectional area is A. And at point 1, that is at the inlet, the head is H in, and at outlet, that is at point 2, H2 is H out. And the difference between H in and H out is head loss, that is delta H, which we had seen that delta H is equal to H1, that is H in, and H2, that is H out. L is the length of the soil sample. So delta H divided by L will give us hydraulic gradient I. Next we'll go through validity of Darcy's law. The flow of water through soils depend on dimension of particles. In fine-grained soils, that is clay, silt and fine sand, the dimensions of the interstices, that is voids, are very small and flow is laminar. Flow is laminar if Reynolds number is less than unity. In coarse-grained soil, that is coarse sand, gravel and boulders, the flow is laminar, but in very coarse-grained soils like gravels, the flow is turbulent. The maximum diameter of the particle for the flow to be laminar is 0.5 mm. For Darcy's law to be valid, the relation between velocity v and hydraulic gradient I should be linear. In extremely fine-grained soils like colloidal clay, the interstices are very small. The velocity is hence very small, and in such soils the Darcy's law is not valid. Thank you.